Everyone remembers the day math betrayed them. You're sitting in class, staring at a clean whiteboard, numbers neatly lined up in rows, and then, suddenly, the teacher writes a letter, not a number, not a digit. A letter. X. And just like that, math stops making sense. You sit there wondering who decided to mix the alphabet with numbers? Why does this mysterious X always need to be found, like a lost treasure in every equation? It feels absurd, yet it's everywhere. The heart of algebra, the language of science, the foundation of logic itself. But X wasn't always there. For thousands of years, humans did math without it. There were no symbols, no variables, no abstract placeholders for the unknown. Mathematics, in its earliest form, was storytelling, a slow dance between language and logic, where problems were described in words, not symbols. And then, somewhere in the folds of time, someone made a leap so radical that it reshaped human thought forever. They decided to name the unknown, to represent mystery itself with a single letter. This is the story of that letter. It's a journey across 4,000 years, from clay tablets and temple walls to Arabic manuscripts, French scholars, and the blackboard of a modern classroom. A journey through philosophy, language, and the strange beauty of abstraction. This is the untold history of how the alphabet invaded mathematics and why X became the most famous letter in the world. When numbers were sacred, the age before algebra, long before numbers became tools, they were symbols of divine order. In ancient Babylon, Egypt, and Greece, mathematics was not taught, it was revealed. Numbers were woven into religion, architecture, and astronomy, forming a sacred code that mirrored the universe itself. The Babylonians, around 1800 BCE, carved equations into clay, but they didn't think of them as we do today. Each problem was part ritual, part record, the measurement of a field, the partitioning of grain, the alignment of a temple to the stars. Their math was born out of necessity, but framed in reverence. To calculate was to understand the god's design. Egyptians, too, used math not as a science of symbols, but as an art of proportion. When they built the pyramids, they used geometry instinctively, ropes and shadows, triangles and ratios, yet they wrote their problems in sentences. No letters, no variables, just words, laid out like instructions in a recipe. If you divide the bread among 7 men, each shall receive. Every calculation was a line of language, and every answer a narrative conclusion. Math was a story, not an equation. This ancient mathematics was concrete, visual, and grounded in reality. A field had a measurable width, a triangle had a visible side. There was no need for abstraction. Numbers were things, not ideas. And for a time that worked perfectly. Humanity built cities, measured stars, recorded debts, all without ever needing to imagine an unknown. But hidden in the language of their measurements was a limitation waiting to be broken. What happens when you don't know something but need to represent it anyway? That question, that subtle, dangerous curiosity, would eventually pull mathematics into the world of symbols, abstraction, and letters. But it would take another 2,000 years for anyone to dare to write what could not be spoken. Clay, geometry, and the world before symbols. If you were to walk through the bustling markets of Babylon in 1800 BCE, you'd see rows of scribes sitting with wet clay tablets, pressing wedges with their reed styluses. These weren't artists or poets, they were record keepers of the ancient world, accountants for kings and temples. Their tablets tracked everything from cattle and taxes to the dimensions of irrigation canals. Yet, among these records, archaeologists have found something unexpected: equations. Problems so sophisticated they could rival those in modern textbooks, quadratic equations. Systems of proportions, geometric reasoning, all done without a single symbol or letter. Instead of X, the scribes used phrases. They would write, "You have multiplied and obtained. You have added and found." It was step-by-step reasoning, captured in words rather than algebra. Their mathematics was verbal logic, closer to storytelling than calculation. A Babylonian equation read more like a riddle than a formula, each problem a narrative to be unraveled. The power of their method lay not in symbols but in structure, in the rhythm of reasoning. Across the desert in Egypt, a different kind of mathematics thrived. The Rhind Papyrus, one of the oldest math texts in existence, doesn't contain a single variable. Instead, it's filled with sentences explaining how to measure fields, divide bread, or distribute work. Egyptian geometry was practical, physical, born from stone and rope, not ink and imagination. Their word for square didn't mean for equal sides. It meant the act of squaring something, of building it in real space, to an Egyptian scribe. Math was craftsmanship. And yet, as brilliant as these early systems were, they all shared the same flaw. They could describe the world as it was, but not as it could be. Without symbols, there was no way to represent possibility. To explore the unknown, humanity first had to invent a way to name it. That name would not come from Greece, nor Rome, but from a land where math was written in poetry. When math became poetry, India, and the birth of the unknown. In ancient India, mathematics was sung before it was written. The scholars of the Gupta Empire, men like Aryabhata, Brahmagupta, and later Bhaskara, expressed formulas through Sanskrit verse, encoding numbers and rules in poetic rhythm. This wasn't a matter of style, it was necessity. In a culture where knowledge was transmitted orally, poetry was the best form of memory. Each mathematical law had a rhythm, each formula a melody. Their mathematics lived in sound. Brahmagupta, writing in the 7th century CE, performed a miracle of thought. He treated zero not as nothing, but as a number. He also explored negative quantities and the notion of unknowns. Yet he didn't use symbols or letters. Instead, he used words, terms like ibvatfavat, meaning as much as it is. When he solved what we'd now call a quadratic equation, he described it entirely in language. Multiply the unknown by itself, add the product of the coefficient. To a modern reader, it feels poetic, because it was. This Indian tradition, fusing mathematics with linguistic beauty, would travel far beyond its homeland. Sanskrit texts were translated into Arabic and through them. The seeds of algebra were sown in the Islamic Golden Age. Indian mathematicians had already imagined unknowns, zero and negatives, but they had not yet condensed them into symbols. They had the ideas, but not the shorthand. And that shorthand, that moment when the unknown became a thing that could be written with a letter, was about to emerge from the hands of Arabic scholars in Baghdad, in a place known as Beit al-Hikmah, the House of Wisdom. The House of Wisdom, where algebra was born. It is the 9th century CE, in the heart of Baghdad. Under the Abbasid Caliphate, a grand institution flourishes: a library, observatory, and translation center, all in one. The House of Wisdom was unlike anything the world had ever seen. Greek philosophy, Persian astronomy, Indian mathematics, all gathered under one roof. Here, knowledge was not divided by culture. It was fused, transformed, and reborn. Among its scholars was a man named Muhammad ibn Musa al-Khwarizmi, and he was about to change the human mind forever. His book al-Jabr, Mukbala, written around 820 CE, was the first true treatise on algebra. If the word al-jabr meant reunion or restoration, the act of balancing an equation, from that word we get algebra. Al-Khwarizmi's method was elegant. Take what is missing and restore it to wholeness. But what's remarkable is that his algebra used no symbols at all. Every equation was written out in full Arabic sentences. Square and 10 roots are equal to 39. That's what we would now write as x squared plus 10x equals 39. He was solving equations in the modern sense, but through pure language. His approach was logical, step by step, and utterly revolutionary. He gave form to the idea of the unknown. And in his writing, one word appeared again and again: shay, meaning a thing. The thing you don't yet know. It's the something waiting to be found. Shay would travel far. It would be translated, misheard, and reborn as a symbol. And centuries later, that thing, the mysterious shay, would evolve into a single letter. It's the letter X. The Arabic Revolution, Al-Khwarizmi, and the birth of al-jabr. It begins in the dusty, sun-drenched streets of 9th century Baghdad, a city that hummed with thought. Under the Abbasid Caliphate, the world's greatest minds gathered at a place called Beit al-Hikmah, the House of Wisdom. Within its marble halls and fragrant gardens, mathematicians, philosophers, and translators labored together, stitching knowledge from Greece, Persia, and India into a single intellectual fabric. And among these scholars stood one man whose name would echo through centuries: Muhammad ibn Musa al-Khwarizmi. Al-Khwarizmi wasn't just solving equations, he was defining what it meant to solve one. in his book Kit Bal-Jabr, Wa el Mukbala. He describes systematic procedures for balancing and simplifying equations, a method so powerful that even today, the very word al-jabr, meaning restoration, survives as algebra. But what's striking about his work is what it didn't contain. No symbols, no letters, no shorthand. Instead, every operation was written in flowing Arabic sentences. Square and 10 roots are equal to 13/9, he wrote. What we would now express as x squared plus 10x equals 39. In these lines, logic and language merged. His equations read like prose, not puzzles. The word shay appeared over and over again, an Arabic term meaning a thing or something. It was his placeholder for the unknown. To him, shay wasn't a letter or a variable. It was a concept, the shadow of mystery that reason must illuminate. But as his texts spread westward, translated and retranslated across cultures, that shay would begin to mutate. Through translation, pronunciation, and misunderstanding, the seed of modern algebra was quietly taking root. Al-Khwarizmi could never have known it, but that simple word shay would eventually transform into the world's most famous letter. The day someone tried to pronounce it in another language, history took a turn, and from that turn, X was born. The word shay, the invisible thing that became the letter X, the journey of shay. The Arabic thing is one of the strangest linguistic accidents in the history of science. When Al-Khwarizmi's works were translated into Latin during the 12th century, Europe was just waking from the intellectual slumber of the early Middle Ages. Arabic texts poured into Spain and Sicily, carried by scholars desperate to reclaim lost knowledge. In the city of Toledo, where Muslim, Jewish, and Christian thinkers worked side by side, the translators faced an unexpected problem: what to do with the word shay. Arabic script posed a challenge. It had no direct equivalent in Latin phonetics. When they tried to render shay, the Spanish translators pronounced it shay, but the sound sh didn't exist in the Old Spanish tongue. So they did what translators often do. They replaced it with the closest sound available, the soft, whispering letter X. Thus, al-shay the thing became xi in translation. Later, when Latin mathematicians copied the text, they shortened xi to simply X. And just like that, the symbol we all learned to fear in algebra was born not from design, but from linguistic convenience. It's a strangely poetic twist. The unknown became X because someone couldn't pronounce it. Dodwen had once been a spoken idea. The thing we seek became a written symbol, cold, abstract, yet infinitely adaptable. The Arabic shay had been intimate, philosophical, human, but X was pure logic. It could travel, multiply, expand, and generalize. It could live in equations and survive translation. By the time X entered the vocabulary of European mathematicians, its meaning had detached from its origin. The scholars who used it didn't know it was once Arabic. They only knew it stood for mystery. It was the letter for something unseen, a silent container for the unknown. And it would soon become the cornerstone of a revolution that changed how the human mind worked. The birth of symbolic algebra. From scrolls to symbols, the medieval bridge between worlds. For a long time, Europe resisted the power of symbols. Medieval scholars were trained in logic and theology, not mathematics. They believed that numbers were divine, not mechanical, reflections of God's order, not tools to manipulate. But as translated Arabic texts flowed into the universities of Spain, Italy, and France, something began to shift. A new kind of mathematical thinking emerged, one that no longer depended on the tangible world. Instead of counting sheep or measuring land, mathematicians began solving for things that existed only on parchment, imaginary quantities. Invisible relations, unknowns. The transition was slow, even painful. In the 13th and 14th centuries, mathematicians like Fibonacci still preferred words over symbols. Equations were written out in long sentences. The cube and 6 roots are equal to 20. But some began experimenting. They used abbreviations, then letters, then notations borrowed from scribes. Gradually, equations stopped looking like sentences and began to resemble systems. In monasteries and universities, monks debated whether these abstractions were dangerous, whether representing the unknown in letters was an act of arrogance, an attempt to speak God's language. To imagine a number you couldn't see or a value you couldn't measure was, to them, a kind of heresy. Yet the hunger for precision was stronger than fear. Scholars like Jordan Nis, Nemorius, and later Nicola Riesum began using letters for generality, for patterns that held true for all numbers, not just some. By the late Middle Ages, mathematics was no longer just a practical craft. It had become a language of thought. And the alphabet, that simple, everyday set of symbols used to write prayers and poems, had quietly crept into the world of numbers. What began as whispers in translation would soon roar through Europe's universities, and when it did, one man would give this hybrid language its form and its grammar. François Viète, the French lawyer who invited the alphabet into math. The year is 1591. France is in turmoil, wars of religion, political conspiracies, and shifting power. But amidst the chaos, a lawyer named François Viète sits in his study, surrounded by geometric diagrams and Latin manuscripts. Viète is not a mathematician by profession. He's a codebreaker, a cryptographer, and an advisor to kings. Yet his true passion lies in the hidden order of numbers. And it is Viète who would perform one of the most profound transformations in human reasoning. He would bring the alphabet into mathematics deliberately. Before Viète, letters had appeared in math occasionally, almost experimentally, but Viète formalized it. He assigned consonants to known quantities, A, B, C, and vowels to unknowns, A, E, I, O, U. It was an elegant system, one that turned math into a kind of structured language. In doing so, he made algebra universal. His equations were no longer about specific numbers. They were about relationships that could hold true for all numbers. For the first time, you could write a formula that described an infinite family of truths. Viète's work was revolutionary not because it introduced letters, but because it made generalization possible. The power of algebra wasn't in finding one answer. It was in expressing all possible answers. Mathematics was no longer a sequence of steps. It was a grammar of logic. Letters were no longer intruders from the alphabet. They were the architecture of abstraction itself. To his contemporaries, Viète's notations were bizarre, even uncomfortably new. But they spread fast, copied by scholars who saw their power. And among those who studied Viète's method was a man who would strip away the vowels and consonants, simplify everything, and create the algebraic language we still use today. His name was René Descartes. Descartes and the Age of XYZ, the birth of modern algebra. In 1637, a book appeared that would define modern mathematics, La Geometrie, by René Descartes. In it, he merged two worlds, geometry, the ancient science of space, and algebra, the new language of letters. He showed that every curve, every point, every motion could be expressed as an equation, a balance between numbers and symbols. It was the birth of analytic geometry and the birth of modern thought. Descartes simplified Viète's alphabetic system. Using the first letters of the alphabet A, B, C for known quantities and the last letters X, Y, Z for unknowns, it was a neat, orderly division, and it stuck. The letter X, which had already drifted into mathematics from Arabic shay, now found its home at the end of the alphabet, eternally tied to mystery. Descartes didn't invent X, but he canonized it, gave it permanence, a grammatical position in the mathematical sentence. Under Descartes, algebra became language, not of poetry or religion, but of reality itself. He didn't just solve problems, he translated the universe. Geometry, once the study of visible forms, became a language of invisible relationships. Lines became equations, circles became systems. And at the heart of it all was the letter X, the silent emblem of the unknown. From that moment onward, X would escape the classroom and enter culture itself, symbolizing mystery, secrecy, and the unreachable. It was no longer just mathematics. It was the human fascination with what cannot yet be known. Newton, Leibniz, and the explosion of mathematical language. By the 17th century, Europe was no longer whispering about numbers. It was shouting them. The world had entered an age of telescopes, experiments, and restless minds. And in that whirlwind stood two men, both brilliant and both haunted by the same question: how do you describe motion itself? Isaac Newton and Gottfried Wilhelm Leibniz lived in different countries, spoke different tongues, but both sought the same miracle: to write change. Geometry had given humanity the tools to describe where things were. Algebra could describe what they were. But calculus, this new language, would describe how things become. For that, numbers weren't enough. They needed something lighter, faster, more abstract. Letters that could dance, combine, and vanish like thoughts. Newton's notes were written in compact English-Latin mixtures, full of letters and strange marks that only he could read. He invented his own notations, dots over variables to show speed and acceleration, a private shorthand. For the laws of motion that would shape physics forever, Leibniz across the sea created his own elegant system using dy and dx to express infinitesimal changes. His notation survived because it was beautiful, logical, and human-readable. For the first time, letters no longer stood merely for unknowns. They represented relations. They moved. They transformed. Algebra had evolved into something deeper, the living language of the universe. Every falling apple, every orbiting planet, every beam of light, all could be described by combinations of letters and symbols. When Newton looked at his equations, he wasn't seeing ink on parchment, he was seeing reality. And for the first time in human history, reality was speaking back in letters. X means the unknown, the psychology of mystery in numbers. There's something eerie about the letter X. Even outside math, we instinctively know what it means. X marks the spot. The X-Files. Brand X in every context, X stands for something hidden, something yet to be revealed. But why? Why not A, or Q, or M? Why has X, a letter barely used in most languages, become our universal symbol for mystery? Part of the answer lies in history, that long chain from Arabic shay to Spanish shay, to the simplified X of European math. But part of it lies in psychology. The letter sits near the end of the alphabet, almost an afterthought. Its shape, two intersecting lines, has always carried symbolic weight. In ancient cultures, crossing lines meant destiny, convergence, or secrecy. On maps, an X didn't just show a place, it hid it. It invited discovery. So when Descartes chose X, Y, and Z for his unknowns, he wasn't just being systematic. He was subconsciously invoking an ancient pattern, a mark that represents the threshold between the known and the unknowable. The letter X became a portal. And from that portal, all modern science stepped forward. Over the centuries, the symbols spread beyond math. In chemistry, X became the unknown element. In physics, it meant an undetermined factor. In pop culture, it meant the forbidden, the mysterious, the seductive. Every time we use X today, whether in an equation, a brand, or a story title, we echo a millennium-old idea, that the unknown is not to be feared, but to be solved. That idea, more than any theorem, changed the way we think. The legacy of letters, how algebra rewired the human mind. It's easy to think of algebra as just another subject, something scribbled on school blackboards and quickly forgotten. But beneath its symbols lies one of the greatest revolutions in human cognition. Before algebra, people thought concretely. Math meant counting sheep, stacking stones, or building pyramids. After algebra, humanity learned to think abstractly. We learned to manipulate ideas that didn't yet exist, to imagine infinity, to symbolize possibility, to think about what might be, not just what is. When letters entered math, they gave birth to imagination and numbers. A symbol like X wasn't just a placeholder. It was a mental space, a promise that something could be found there. Algebra taught humanity to trust symbols, to believe that meaning could exist beyond what we can see. It gave rise to modern science, to physics, to the digital algorithms that now shape our lives. Every time a student solves for X, they're reenacting a ritual that began over 1,200 years ago in Baghdad, in Toledo, in Paris. Every X carries the weight of a civilization's curiosity. It is the mark of every human who ever asked, "What lies beyond what I know?" And that, perhaps, is the true legacy of letters and math. Not just new symbols, but a new way of seeing the world. A world where even the most mysterious X is not an enemy, but an invitation to understand. The next time you see X on a page, remember, it isn't just a symbol your teacher made you memorize. It's a ghost of history. It's Al-Khwarizmi whispering from a Baghdad library. It's Descartes drawing lines between the visible and the invisible. It's every mathematician, poet, and philosopher who dared to put a letter where there was once only a number. Because math isn't about numbers, it's about language. the only language the universe has ever spoken fluently. If you've made it this far into the story, thank you for exploring with us. There are still countless mysteries hidden inside what we think we already know. Subscribe and step with us beyond the ordinary, because every question has a story. And sometimes, even an X can mean everything.